This life is all about time. When my time comes, no one can stop me. One thing I love about myself is that I encourage myself. I motivate myself. I believe in myself, and I know God won't fail me.
Substitution. But let us try and see if it will work in this case. Now, the first one is lim s squared minus 4 all over s minus 2 as s tends to 2. So using that method now, let us see whether it will work. When you put 2, check very well. When you put 2 to be 2, you have 2 power 2. Is it not 4? Then we say 4 minus 4. Here, 2 minus 2, 0, 0. This is not good for us. It's not good, in fact, it's not good for our health at all. So we have to use what? We have to use another method. Now, what are we going to do? We differentiate the numerator and also differentiate the denominator so that we will not have this form. Now, therefore, this implies that we're going to say limit of, let's find d dx. That is, we differentiate s squared minus 4, and we also differentiate what? D dx of s minus 2. That is, as s tends to 2, we differentiate the numerator, also differentiate the denominator. Check it very well. Differentiating s squared now, we have 2x. But when you differentiate a constant, you have what? 0. So that's why I say minus 0. The same thing as what? 2s. All over. Differentiating this one now. Differentiate x, you have 1. Alright? Differentiating 2, you have 0. So the answer is 2s. So now, you can now substitute your s to be 2. So it can now be 2 times 2, which is equal to 4. As you can see now, it's very, very simple. It's no more giving us this indeterminate form of 0 over 0. Now, number 1 has been answered. Number 2 again. An attempt to substitute s to be 0. Here, look at it. When you say cos x minus 1, all right, all over sine x as s equal to 0. When you put cos 0 here, you have 1. Cos 0 minus, that is 1 minus 1 is 0. So this is going to be 0 all over 0. Because cos 0 is 1. 1 minus 1 is what? 1 minus 1, as in here now you have 0, then sine 0 is also 0. So at the end, we have 0 over 0, which is still not good for us. And then what are we going to do? We use the same method above. So it will now be with different, we say lim now d dx of what? Cos x minus 1 all over d dx sine what? Sine x. Now, differentiating cos x, what are you going to have? When you differentiate cos, you have minus sine x. And differentiating this one now, you have 0, so there's no need of bringing it. All over, differentiating sine x, you will have what? Cos x. So now, you will now substitute. Anywhere you see s, you put what? 0. So it will be minus sine what? X, which is sine 0, all over cos 0. And now, sine 0 is equal to 0. Then cos 0 is equal to 1. So 0, that is sine 0. So 0 all over 1 now is equal to what? 0. So thank you very much. With this one now, we are good to go. And join me again for another interesting example on limits limits using another method. Thank you very much.